Hello my dear students, how are you all? Welcome back to our YouTube channel Diksha Karnataka. I hope all of you are very good. Yes, today I am back with part 2 of our ongoing chapter, which is application of derivative. Part 2. In this chapter we'll discuss what, bacha? This will discuss increasing and decreasing function. Today is what? Today is day 23 of our ongoing series 60 out of 16 KCET mathematics in 100 days. I hope all of you are doing questions right with me. Okay, not just watching the videos. Whenever you are watching the video, make sure that you're solving questions together, right? Because there's a point of the video, right? You are supposed to solve the problems, learn some things, and then help your preparations. Okay, we have a big goal ahead of us, so we have to be very much punctual, disciplined with our work. Okay, I hope I am delivering from my side. I want you to deliver from your side as well. Get in comments, answer your questions, ask your doubts. I'll answer your questions, ask your questions. Okay, chaliye. So today, in the previous session that we had for the part 1 of this chapter, so what we did, we talked about rate of change of quantities, right? In that we talked about velocity, we talked about volume, area, acceleration. We saw some curves also. Okay, we saw the graphical interpretation of the derivative. We also learned that. Okay, how can a tangent be, the line becomes tangent, the slope part we also discussed. Okay, and we saw simpler problems on that topic. It was a very simple chapter. It was a simple session, not that complicated. First session was very simple. Now here, this also is very simple session, not very complicated. This chapter itself is very easy. Okay, it does not involve very complicated differentiation problems. So simpler problems, the goal is different. The goal is to identify whether the given function is increasing or decreasing, right? The goal here is very different. The goal here is to identify whether the given function is increasing or decreasing. Am I right? Yes, sir. Okay, chaliye. So with this known, what we're doing here, we're starting with the first question or the concept, not the question, first the concept. When can we say a function is increasing? When can we say a function is increasing? So, when we hear this word increasing, together, if you have learned little bit also in before this session, you'll know the other word comes, what is it? Strictly increasing, sir. So we'll see the difference between them right now. For now, just understand when can we call a function increasing. I hope you understand this. Even if I say a function is strictly increasing, it means what? It is increasing only, right? Strictly increasing means it is always increasing. But it is what? What is the nature? Increasing only. Excellent. Chaliye, let's read this. Increasing function, a function f is said to be increasing function. Said to be increasing function, provided that x1 and x2 is what? Part of your integers or any domain. Okay, I can write this as, okay, so over here there is a defined interval. There is a defined interval. What is that? Interval I. But if I look at the graph, I can say all real number also. Okay, this interval can be a defined interval as per the question, or in this graph you can see it is a real number. Okay, so for any particular interval or wherever it is defined, okay, the function, if I take a number, two numbers I take from the domain x2 and x1, such that x2 is more than x1, bacha. For example, in this particular question, I can take, let's say, x2 to be 5, x1 to be -1. Is 5 more than -1? Of course, sir. So what is the value of the function at 5? Obviously, it will be somewhere here. Please check. Somewhere over here. Isn't that value of y more than the value of where it is? Let's say it is -1 is over here. So this is -1. So I get this value as y2 and this value as y1. Okay, so can you not say from here in the graph only, cannot say from the graph only directly, that f of 5 is nothing but y2 is simply more than f of -1, which is over here. Can be written as simply what? y1, right? I've taken it as y1, no, in the curve. So I'm taking across -1, I'm taking it as y1, across 5 I'm taking it as y2. Okay, so what I'm trying to say here is f of 5 if I've taken as y2 and y1, so at 5 my value is y2. If 5 is more than -1, of course it is more than -1. Where is 5 from? 5 and -1 from the domain or the interval where the function is defined. Okay, then if you take that, if you consider that, then function value will also be coming in this way if you have this condition. Means for x2 to be greater than x1, if you get corresponding value of the function at x2 and x1 to be of the same order, greater than, then I can say function is increasing, sir. Function is increasing. Same you can see. Okay, now let me erase this part. I don't need to complicate and show this like this. Okay, please see here, as I Okay, 1 second. As I move across x-axis, so how I'm going to move from left to right, what's happening to y? Y is going up and up and up. It means y is increasing. No, if I'm increasing x value across x, y is increasing across y. It means obviously the function is increasing type. Moving on to the next part. This is your favorite type. What is it called? Strictly increasing, sir. There's a confusion, sir. Is there really? Look at the graph. As I move from left to right, the function value, the y values, the corresponding values are increasing. Then why this is strictly increasing and this is not? Because if you check here, this branching, this straight line, for some interval from here to here, please check. If I call this to be, so let's say A, and this call this to be B. So in the interval A comma B, in this particular interval, the function value is constant. Fx, okay, is not changing, bacha, is not changing. Now, if function value is not changing in this interval A to B, what can I say? I can simply say it is not strictly decreasing, okay? Sorry, increasing. Means it is not decreasing, of course. Means, does it mean, the answer is here. Is it decreasing? Just because it has stopped over here. Between A and B, it has stopped, but is it decreasing? A and B, no change. Means, is it decreasing? Not decreasing. So, I can call this function to be non-decreasing also. I hope you understand this. Non-decreasing, I can call this function to be. This graph can also be called as non-decreasing. I can call it to be because non-decreasing means what? Increasing. But some people can argue, some students can argue, sir, at this interval A to B, it's not increasing. So I can rewrite this function as non-decreasing. Okay. So, but in the case of strictly increasing function, what will happen? There will be no equal to sign. You can see here, there is no equality here. Look at this. There was an equality here. Like greater than equal to was there. Okay. Over here, there is no equality sign like this. Okay. There is no equal to sign like this. Okay. So the function value is never constant, always increasing. Keep moving towards right in x, y is moving upwards. So this is called the condition where x2 is greater than x1. fx2 will always be greater than x1, not equal to. Okay. This is the strictly increasing case. Okay. Okay, let's look at the first example. We'll see what type of case is this. No. So how do we define this? So how to test it, we'll learn it right now. I was about to test it with the function, but we'll learn it in the next step. Next slide that will come. But before going to that part, let's see if we can we'll try to draw the function. Okay, and then we'll understand whether it is increasing or decreasing. From what? From the graph only. How can we define this function? Y equal to what, bacha? 7x minus 3. I can use the graph also, I can use the value also. Take x value as 1 and x value as 2. X equals to 1 I am taking, x equals to 2 I am taking. Okay. x1 is 1, x2 is 2. What is my fx1? Please tell me. What is my fx1? So it will be 7 minus 3, right? X is 1, so 7 minus 3 will be 4. What is my fx2? Tell me. fx2 is 2, right? So x2 is 2 means 14 minus 3 is 11. Tell me, if x2 is more than x1, is it not? 2 is more than 1, then what I'm getting? I'm simply getting fx2 greater than fx1. Yes or no? From algebraic method I'm getting this. Excuse me. What about this? If I draw the graph at x equal to 0, y value is how much? Minus 3. And when y is 0, what is the x value? 3 by 7, I guess. 3 by 7 will be somewhere here. So this is my curve. Okay. This is my curve. Now if you look at this function, I'm saying that y equals to 7x minus 3 is there, right? Put x as 0, y is minus 3. Okay, y is minus 3, somewhere here. Now put y as 0, 3 will come here, so 3 by 7. This is 3 by 7. Look at this graph. What is this graph? Y equal to 7x minus 3. 7x minus 3. Okay. Okay. Now if you move this graph from left to right, what is happening to the y value? Increasing, sir, all the time. Why, sir, like this? Again, it is given as on the real number. Define on the real number. Okay. So I can take all the real numbers like this on the number line. Negative of infinity to positive infinity. If I move from here to here, what is happening to the y value? Going from negative to positive infinity again. Okay. I hope this is clear. So this is how we understand this question. Moving on. Decreasing function, just reverse, means if I have this condition, bacha, x2 is more than x1, then what will happen? fx2 will be less than equal to fx1, right? In the previous case, what was it? Greater than equal to. In this case, what will be? Less than equal to. Look at the graph now quickly. It's decreasing. As I move from the x-axis, left to right, what is happening to the y value? Check here. It's coming down, na? Coming down, right? Not able to relate? Please check. If I'm checking at this value, my y is over here. If I'm checking at this value, let's say my y is over here, okay? Over here. Isn't it decreased? Isn't there a drop? If I move from left to right, what is happening to the y value? Y is coming down, sir, coming down. If I take x value over here, okay, what's the y value? Over here, sir. So every time I move from left to right in x-axis, y value is coming down and down. The function is what? The function is decreasing, sir. The function is decreasing, sir. Let me erase this part. Okay, chaliye. So now let's move on to the next part. Strictly decreasing means there is no gap. Previous one, check here. At if I define this interval again like C and D, let me define this interval C and D. So in this interval C and D, please check here. In this interval C and D, what is happening to the function? Function is undergoing no change. Undergoing no change means value remains same. Okay. So I can call this function to be what? Non-increasing also. Please understand this. Non-increasing function. Yes or no? Even though it has stopped decreasing, but it is not increasing, right? So it is decreasing, stopped, remained constant, decreasing, constant. Please understand this. Decreasing function, constant function, then again decreasing. But is it increasing anywhere? No, sir. That's why I can call this function to be non-increasing also. Whereas for this function, I have to call what? I have to call it to be strictly decreasing. Why? Because check here, at any point there is no constant. There is no constant. Okay, the function is not constant. Is at every point from x to y. Across x, if I'm moving left to right, my y value is coming down, down, down. Okay, so strictly decreasing, sir. Strictly decreasing, sir. What's the condition here? x2 greater than x1. Okay, what happens? fx2 will be simply less than x1, sir. There will be no equal to sign. Please check here. Here there was a equal to sign. Less than equal to was there, but in this case, I will not have any equal to sign. I hope this is clear. Okay, I hope the definition of decreasing and increasing function is clear. You're able to relate with the graph. Okay, chaliye. आगे बढ़ते हैं. Now, how do we determine it? How do we determine the function to be this? So we have what rule? Okay. First derivative test we have to do to know whether the function is increasing or decreasing. Whether the function is increasing or decreasing. Kar lete hain. What we gonna do? So first of all, derivative means what? It has to be continuous, na? Where? In the differentiable, in this interval, and differentiable where? A to B mein, okay? End point not required, okay? Only A to B. Chaliye. If, understand this first statement. This was increasing function. For f to be increasing, the derivative, which derivative, sir? First derivative, what is this? F dash of x is what is it? First derivative, right? So the first derivative of the function fx or the f should be greater than 0. If you get that, okay? Where for each and every value in AB, means whatever the points are lying between A and B, whether it is 2 points, 3 points, infinite number of points, at every single value in that interval, okay, this has to be positive. This has to be positive. When that happens, which has to be positive? This derivative has to be positive for every single value. Let's say I have 3 values. Let's say between A and B I have x, y, z. I have x, y, z, okay? So what I have to do, this f dash at x should be positive, f dash at y should be positive, and f dash at z should also be positive. I hope you understand this, okay? I hope you understand this. If it has 10 values, for every 10 values, infinite values at every values from that set, okay? About decreasing, just reverse, it'll be the derivative should be less than 0. For decreasing, derivative should be what, bacha? Less than 0, okay? This will be decreasing in the, again, at every point in the domain, okay, x, a to b. Constant function means it will be equal to 0. Correct, right? Derivative is equal to 0. Anyway, if you, I hope you know this. Any line which is parallel to x-axis, what is the slope of that? Slope of that is what? I hope you remember this. Slope of a line parallel to x-axis. Slope is always 0. And we learned in the previous session, what is slope? Slope is my nothing but dy by dx. And we also call this as f dash of x or y dash, right? This is coming as 0. I hope you understand this. This is a constant function, right? Y equal to, I can write it as some number k. So for y equal to k function, slope is always 0, we know that. And we write slope as dy by dx can also be rewritten as f dash of x, which is equal to 0. That's what it's saying. For a constant function, derivative will come as 0. Okay, again for every element in the domain A to B. Simple है, yes. Points to remember. चलिए कुछ चीजें याद रखने की है. Let's remember some things. What is it? fx is strictly increasing, sir. मतलब there will be no constant place in between if it is this for each and every value. Same thing I said right now. For every value in A to B, if it is always increasing, not at one point it is coming as constant, I'll call it as strictly increasing. Same goes with decreasing. If it is always less than 0, I'll call it to be what? Strictly decreasing, provided that the number x should be between A and B again. Okay, a function will be increasing or decreasing. It can be increasing or decreasing if, okay, if it is, this is true for every subinterval in R. What's the meaning of this, sir? What's the meaning of this? Think about it. Let's go back to this first slide, not this one. So let's talk about with respect to decreasing function. What is the actual interval in this case? Interval is I. Okay, I can call this I to be what? Real number also. Call this function to be real number also. If this is real number, isn't C to D also an interval? I can call this interval to be I1. For this interval I1, the function is what? The function is what? Non-decreasing, non-increasing. If it was like what? If it was decreasing or increasing, if this also was decreasing, I can say the function is strictly decreasing, right? Because I1 is what? I1 is a subset, understand this, subset of I. What is I? I is an interval which is set of what? All real numbers, okay? I1 is only from C to D. So even C to D is a real number set, but I can call I1 to be a subset of I. In this particular case, I1 is not decreasing, not increasing. Only it is a constant function. But if I have a case where for every subset, please understand this, for every subinterval of R, okay, if the function is either increasing or decreasing, I can call the function to be increasing or decreasing, sir. Okay, now note, if f is differentiable in A to B, okay, and discontinuous at x equals to A and x equals to B, okay, means I can draw a function like this, okay, means at this point A, the function has discontinuity, and this like this, okay, this also at B also discontinuity, but over here is differentiable. Over here it is differentiable. Please understand this. I can draw the graph in two ways. Okay, this is my point A. Looks little like tirsha, like little inverted, but no problem. This is again my point A. This is my point B, right? AB, again AB. At A, there's a break in the function. You can see here at A, open. At B also it's open. At A it's open. At B it's open. I've taken two different functions. It's always increasing when what? When this is always present. Means if the derivative is positive, I can call the function to be increasing. Otherwise, you can call the function to be decreasing. Provided what? Provided the function should be differentiable. What? Differentiable. I'm talking with respect to only what? Increasing function. So let me just show it to you. Provided that the function is differentiable everywhere between A and B. See, differentiable between A and B, even if it is continuous at A and B, okay, and this condition is true, f dash of x is greater than 0, I can call what? I can call this function to be increasing. What type of increasing? Strictly increasing. You can see here, strictly increasing in A to B. Okay, a note here. Can we move on? Yes, sir. Okay. Now we'll talk about again a few more things. Let's see. If f is continuous in A to B and differentiable in AB, okay, here continuity is there. The previous one was at A and B was not continuous. Over here continuity is there. When it was not continuous at A and B, I wrote it as strictly increasing, but now you'll see continuity in A to B, and this is differentiable in A to B, okay, differentiable at open A and B, continuous in close A and B. I will call this to be strictly increasing only if What I'm calling the function f is, I'm calling it as strictly increasing only if at every point, okay, so at one point the equality can be present, okay, but not in an interval. Please understand this. Means at one point the function can be equal, you know, like the function's value can be equal but not at every point. So derivative has to be positive. So usually what we do, if you remember, f dash of x should be positive for what? Strictly increasing function. Strictly increasing function, SI I am writing strictly increasing. But I'm saying that if in the interval like this I have equality present, equality is present like this, no problem. I can give you example. Check this function. Please check this function. Look at this function. At x equals to 0, whatever is the graph, okay, whatever is the graph, if I put this, what is the value of y? It will be 0 only, okay. See, let's say if I take this function to be, let's say y equal to sin x. What's the derivative? Cos x. What's the value at 0? Okay. So if you check here, one second, not this part. If you check here, if you put sin 0, what is the function value? It is 0, sir. It is 0. So even at one point it is coming as 0, but it should not be 0 in an interval. Means at one point, if the value is to be, the equality is present, okay? Okay, even that condition will be valid, provided that this is present. Provided this is present. Differentiability should be in AB and continuity should be in closed interval AB, okay? If that is there, this condition is there, I can say this function to be strictly increasing, sir, strictly increasing. Same goes over here, but in this condition, if equality is present, but not at one point, at some interval like this, okay, means this is the whole interval, right? This is the whole interval. I call this to be I, but if I call this interval, some interval to be I1, any subset, any subinterval of the whole interval, the original interval is I. If for any subinterval, I defined in the previous case also, where I wrote the interval I as the real number and I1 as C comma D. If I take the same condition over here, let's say this is my real number interval and this is my what interval? C comma D. So if this equality is present over all the interval, sub-interval like this, then what will happen? I can call this function to be increasing, sir. Increasing. I will not call it to be strictly increasing. I'll call it to be only increasing. Or also, I wrote this statement. Increasing function can also be called as non-decreasing function. Increasing function can also be called as non-decreasing function. Where? In what? A comma B closed interval. I hope this is clear. Let's see for the decreasing function. Again, continuous in A to B, differentiable in A to B, open interval. Okay, it will be strictly decreasing. In this interval only if this equality here, if you see here equality, usually in decreasing function also there is no equality. If I'm talking about a strictly decreasing function, remember this, I was talking with this na bacha, yes or no, right? There was no equal to sign here, in this case, okay? So if there is equal to sign over here, not a problem, but only if this equality is present only for some points, should be some point, not for the entire subinterval, okay? Whereas in this case you see here holding in some interval. So again I can write this as C comma D. If this is true, if this equality is valid for an interval, then I cannot call this to be strictly decreasing. I have to call what? Simply decreasing. This trend is decreasing, or also can be called as what? Non-increasing function. Decreasing is what? Non-increasing function. Same thing I explained in the definition part also. Chaliye aage badhe. Let's move on. Now working principle. How can we see this? I'll show you the slides, but let me summarize it first. Okay. Well, sir, a summary comes after explanation. There are a lot of things written over there. Okay. Once I'll take simpler steps. 4 simpler steps to solve any question in increasing and decreasing function. Let me show you all the steps first. Then I'll show you the steps from the previous slides also. Step 1, what you're gonna do? First step is quickly find derivative. Okay. And after finding derivative, what you're going to do is put it equal to 0. Whatever was the derivative of the function, find the derivative and put it equal to 0. Okay. From here, what are you going to do? Find out your critical points. Okay. So once you find the critical points, for example, let's say I have a function like this. X minus like this. I have a function x minus 1 the whole square. How can I differentiate this? It will become what? 2 times of x minus 1. Yes or no? What is the critical point over here, bacha? Only 1 is the critical point, right? So if I put this equal to 0, what I'm going to get? X equals to 1 is my critical point. So that's what I'm saying. This is my example here. Okay, not relevant in this part. So if you take a function, this y equals to x minus 1 the whole square. If you take a function like this, I can differentiate. This is my y dash. What is that? This 2 into x minus 1. Put it equal to 0. Same thing I've written here. So after getting this x equals to 1, okay, I have to do what? Plot my critical point. Plot my critical point. So I can plot it like this on the number line. How will the number line look like? Minus infinity to plus infinity. Okay. What's the value here? Simply 1. Simply 1. So what you're going to do to check whether the function is defined in what interval? So if you see here carefully, you have divided this entire number line where in 2 intervals, from here to here and from here to here. Okay. Now what you're going to do? Simply put the values after 1 in this derivative. After 1 I can put what? 2. Put here 2 minus 1 is how much? 1. 2 minus 1 is 1, and that will be a positive number. So I'm getting what here? Positive I'm getting here. Now put a number before 1. I can put 0 also. Before 1, 0 I can put. 0 minus 1 will be a negative number. So I'm getting it as negative. Wherever it is positive, I can call the function to be increasing. Negative means function is decreasing. And then at last what are you going to do? Conclude it. Do what? Conclude your answer. What is my first step? First step can be what, bacha? Look at this. So function is coming as f dash of x is coming to be greater than 0. Where is coming 0? 1 to infinity. 1 to infinity. So 1 is, what I can call this? What I can call this? Increasing function. Increasing in this area. What about decreasing? F dash of x is less than 0. Where? Where? Minus infinity to minus 1. Minus infinity to minus 1. This is my interval. Okay. And this can be called as decreasing. This can be called as decreasing in this region. This region. From here to here is decreasing. From here to here it is increasing. If I get more than one critical point, I'll find for all the values same reason. After that critical point, I'll put a value in the function, check the trend. Before the critical point, I'll put the value and the interval and check the trend. Okay. This is how we do it. Now let's check the steps involved. Chaliye. Working rule to find the interval in which the function is increasing or decreasing. Okay. Look at the first step. Suppose fx is a function where x belongs to r, okay, or x in another interval other than r, okay. I can take this in the real number, okay, minus infinity to plus infinity, or some other interval, okay. For the function, the definition, the domain is given like this. First write the given function fx, okay, and then find what? Derivative of fx, same thing as said. I will quickly read through this because I already explained you this. Put fx equals to 0, second step, put it equal to 0, and then find the values where? Find the values, effective values for the given interval. Once you find the value, what I'm saying, what is this value called? It's critical values. Critical points, you find it out. Once you find that, divide the number line. The number line was like this. Divide it in the intervals using these critical points, okay? Okay, and you create the sub-intervals like this. So 1, 2, 3, 4 you can create. Based upon the number of critical points, you can do that, okay? Chaliye. Step 4, in each sub-interval, check. How will I check? Put a value from the x after that interval, before that interval, before the critical point, and check whether it is following this trend or this trend. This trend means increasing, other trend means decreasing, okay? So again, you know that strictly increasing and decreasing in that particular interval. Step 5, okay? From step 4, we can get those intervals. Of course, conclusion is there. Those intervals which function fx is increasing or decreasing. Okay, I can find out like where it is increasing, decreasing. Like we took the example. If fx is increasing in sub-interval and decreasing in sub-interval, then in the whole interval or a number line, the function obviously correct. If you look at this function, look at the statement. Okay, now look at this. I draw it here. After 1 it is increasing, bacha. Before 1 it is decreasing. So in this particular interval, it is strictly increasing. In this particular interval, it's strictly decreasing. Very good, sir. But what about entire real number? What about entire real number? What about this interval? Minus infinity to plus infinity. What about this? Neither decreasing nor increasing, because the single trend is not there. That's why it said, for if it is both conditions are valid in the same, so like two different subintervals, one where it is decreasing, other where it is increasing, then I cannot call the function to be either increasing or decreasing. That's why neither increasing or decreasing. Okay, चलिए आगे बढ़ते हैं. Problems now. Let's do the questions quickly. First one, I hope you understood this, right? I hope you understood what is increasing function, what is decreasing function, how to check the functions, okay? What are the rules for it, okay? I said 4 rules, I'll repeat. First rule is find the derivative, put it equal to 0, then find the critical points. Third rule, put it on the number line, divide the number line in that sub-intervals. In each interval, put some value from that interval, check the trend. If it is greater than 0, then it is increasing, less than 0, then it is decreasing. Yes, very simple. Very, very simple. I told you the chapter itself is very simple. Okay, आगे बढ़ते हैं. Find the intervals on which the function is decreasing, increasing. कर लेंगे. Let's do the derivative first. First part is finding derivative. Finding derivative of this. What rule we use, बच्चा? I told you there is a prerequisite of this chapter. What is it? Prerequisite is knowing differentiation. If you don't know differentiation, how will you find the derivative, right? Means how will you proceed with anything in this chapter? So it is called what? AOD for a reason, correct? Find this quotient rule we will use. Yeah, but one more thing. Theorems you have to know, like product rule, quotient rule, chain rule, but you don't have to know very complicated differentiations. Only in particular question, very same question, they can ask you a very complicated differentiation. But usually they'll ask you a easily differentiable problem. It will not take that much of time. So कर लेते हैं. Quotient rule means I'll keep for 1 first, so x will be 1, for x will be 1. I'm not going to do all the differentiation steps here because I know you know already. So I've taught you in the previous sessions. If you are still not clear with all the steps in differentiation, go ahead, watch the previous sessions. They have taught the continuity and differentiability. I've taken so many questions, I've solved all the questions, okay, in the P by Q, in the revision side. Make sure that you are going through all the videos, okay, because I'm going to skip some steps here, okay. Not relevant, go back, learn it, then come back and watch this video. So I'm going to do for x first, so it will be 1. I'll keep this part as it is. आगे बढ़ते हैं, आगे बढ़ रहे हैं. Minus sign, what is going to be? I'll keep x as it is. For this I'll get what? 2x divided by 1 plus x square the whole square, correct? X I did for x, I got it as 1. I kept 1 plus x square as it is. Then I kept x as it is. For 1 plus x square, for 1 it is 0. For x square it is 2x. Okay, आगे बढ़ते हैं. So y dash equals to what? 1 plus x square. How much is that? Minus 2x square. Please check here. Correct? Minus 2x square upon what? Yes or no? Yes. How much is this? 1 minus x square upon 1 plus x square the whole square. Differentiate it with this. Okay, one mistake. I'm writing the formula a minus b, a plus b. A minus b, a plus b. Please check here. 1 minus x and 1 plus x upon 1 plus x square the whole square. ठीक है? Now, think about it. This is basically positive number. Square of a number more than 1 will be positive number. It can never be 0 or thing. I don't want to check for this part. Only the critical point will be what? What I said to find critical point. To find critical point, whatever is the derivative, what was the derivative? Please check. Put it as 0. So put it as this derivative as 0. Correct? If this is a non-zero number and it's a positive number, I bring it over here. I can multiply this over here. It will become simply 0. Okay, what is the values that I'm getting? X equals to 1 and minus 1. What is the next step? Second step. First two steps are done. Differentiation and the finding the critical points. Next step was plotting on the number line. What's the number line? Minus infinity to infinity. Yes or no? The points are minus 1 and 1 bachcha. Hai na? Minus 1 and 1. So let's see the trend after 1. After 1 what will happen? After 1. See the trend now. See the trend after 1. If I put anything after 1, the denominator will not change, right? It will be positive number. I have to check only for the numerator part. After 1, this will be positive. More than 1. No, sorry. After 1, right? It will be negative, right? Forgive me. X will become bigger, right? After 1. So this will be negative. This will be positive. What is the product? This is positive. What is the product? Negative. So this is going to be negative. Now check between minus 1 and 1. So a number less than 1 but greater than minus 1. What will this be? Positive. What about this? Positive again. Okay. So this will be positive, bachcha. Please understand this. If you're not getting it, I'll repeat this part. Please check. Okay. I'm talking about between minus 1 and 1. So between minus 1 and 1, I can get what? I can take 0 also. Take 0, 1 minus 0 is what? 1. What I can take? 1 plus 0, again 1. Both are positive. So I can take positive, this is positive. Before minus 1, I can take what? Minus 2. If I take minus 2 here, what will become? This will become positive. Correct? Not getting it? I can repeat this thing. Okay? No confusion. I don't want any confusion in this part. First question we are doing. Okay? We can take some time. I'm asking you to take x equals to what? Minus 2 on the left side of minus 1. This will be what? Minus of minus 2 will be positive. Minus of minus 2 is plus 2. 2 plus 1 is 3. So positive. 1 minus 2 will be what? Minus 1. So negative. Plus into minus. Again minus. This will be negative. Now check here. Wherever it is minus, decreasing. Wherever it's positive, increasing. What are they asking first step? Increasing. They are asking us increasing. I'll write over here only. Increasing, where is the domain? Minus 1 to 1. Right here. Minus 1 to 1. I'm writing answers over here only. Please check. And what about decreasing? Minus infinity to minus 1 and then 1 to infinity. Correct? This is my answer. Simple, very simple question. आगे बढ़े. Let's move on. Question number 2. So that the function given by fx equals to sin x is okay. All right. Now I can solve this question in one step also by just drawing this thing. I can show you the trend and I'll give you the answers. Sine बना लेते हैं from where to where? 0 to pi. 0 to pi. From 0 it will be like this. Pi by 2 पे peak आएगा 1 का. It will be 1. Then come back to pi. At 0 it is 0. At pi by 2 it is going to be its peak value, which is going to be 1. Going to be 1 bacha, right? And at pi it will be what? 0 again. This is the function of sine. This is the graph of y equal to sine function. Y equal to sin x. This is the graph. Okay, think about it. 0 to pi by 2. What's the trend? 0 to pi by 2. What is the trend? Increasing, right? Strictly increasing. 0 to pi. Please check here. 0 to pi by 2. It's increasing. Again, pi by 2 to pi. Look at this. Only this part you look at. Only this part you look at. What's happening on this part? Okay. The function is coming down, so decreasing. So I proved it to be extremely decreasing over here. C part neither increasing nor decreasing in 0 to pi. Of course, because for the 0 to pi in 0 to pi we have two subdomains. 0 to pi by 2 and pi by 2 to pi. In 0 to pi I have both increasing and decreasing property coming together. It means it cannot be either decreasing or increasing, right? So from A and B I can say it is C is also true. C is also true. But this is the graphical part. Let's see how can I solve it? What's the function given? Y equal to sin x. What's the derivative going to be? Y dash equals to cos x. है ना? Cos x. Check for the first part. Cos x. Y dash is cos x. Am I right? Okay. If y dash is cos x, okay, find, put x equals to any value from in between. Okay, what is this going to be? Check here. Cos x between 0 to pi by 2. How much is that? Please check. How much is that? 0 to pi by 2. Always positive. Correct, no? Cos 0 is 0. Cos pi by 2 is, sorry, cos 0 is 1 and cos pi by 2 is what? 0. What's the value over here in between these two values? Always positive. Now some people might get confused here, some students thinking that, sir, but it's decreasing, from 1 to 0 it goes. If you look at the cos graph, the graph goes down, sir, from 0 to pi by 2. Then how is it what you call increasing function? I'm not talking about cos x, I'm talking about sin x, okay? For the derivative, we don't say the trend. For the derivative of this function, we don't see the trend. We see whether it is positive or not. Just tell me whether from 0 to pi by 2, cos x is positive or not. The derivative is cos x, right? The cos x has to be not increasing. The cos x has to be only positive. Question is whether cos x is positive or not in the interval 0 to pi by 2. Answer is yes. So if I write the table, at 0 it is 0, at pi by 3, the 30 degree it is what? 1 by 2, 1 by root 2. Check here. We have learned for special angles, no? Just this clarification I want to give. At 0 it is 0, at 30 degree it is 1 by 2, 45 it is 1 by root 2, 60 it is root 3 by 2 here and 1 by 2 over here. I thought I'm writing for sine. 1 second. This is what? Root 3 by 2. This is what? 1 by 2. At 90 it is 0. So even though it is decreasing, even though, again same mistake, I'm writing for sine, I wrote it as 0. This is 1, right? Even though it is decreasing, the cos x is decreasing from 0 to pi by 2, which is 90 degree, but what is happening here, bacha? It's all positive. It's all positive. It means it is increasing. Please check here. Please check here. It is increasing only. Now some people might ask again, sir, it is 0, no? If it is equal to 0, if it is equal to 0 at 90 degree, this is a good doubt, okay? Think about it. Sir, equality is present here. You said whenever I have the derivative as only greater than 0, equal to, so I cannot write. If it is greater than 0, just greater than 0, I can say strictly increasing. But I have a condition where it is equal to 0 also. But check here, 90 is not part of the domain. It's exclusive, open interval. At pi by 2 it is open interval. Means at pi by 2 I don't have to check this value. Okay, I'm not considering 0 because pi by 2 is not over here. So just before pi by 2 it will be not 0, right? If I take a value right before pi by 2, right, let's say I take 89 degree, it'll be very close to 0, but it will not be 0. I hope you understand this. At 89 degrees, it will not be 0, it will be very close to 0. So again, it will be what? It will satisfy this condition. So the derivative of cos x, in what interval? 0 to pi by 2 is what? Always positive. We don't see the trend here, bacha, only the sign. Derivative of cos x always positive. In that condition, strictly increasing is valid. So I just showed right now. If you have to ask what is the necessary points, I can write only this, and this is true. Okay, I don't have to explain all of this. I can simply say that cos, this also I don't have to write. I can simply write this as cos x is positive where? In 0 to pi by 2 open interval. Correct? Because at pi by 2 it is 0. That's why I'm saying 0 to positive, 0 to pi by 2 it is open interval, then only it is positive. So what I'm getting the condition as? Greater than 0. Greater than 0 means strictly increasing. First option is proved. Okay, same way, look at the second option. I have to take from where to where? I have to take from pi by 2 to pi. Look at the graph of the function. Which function? Cos x, sir. Why cos x, sir? Because what is my derivative? Derivative is y dash equals to cos x. Sir, why derivative we are checking? Because to know the functions increasing and decreasing nature, we check from which? First derivative test. So that's why I'm taking first derivative. Now check here, cos x will look like what? This is my pi by 2 and this is pi. Now you only tell me from pi by 2 to pi, what is the value of cos? Negative, right? Okay, so I can say in open interval of pi by 2 to pi, open interval pi by 2 to pi, what is happening to cos x? Cos x is negative. Cos x negative means what? My y dash is nothing but less than 0. Means what? Strictly decreasing. What is decreasing? Y equal to sin x is strictly decreasing. Is this enough? And since it is increasing and decreasing both condition between 0 to pi, I can simply say what? In C condition, it is increasing from 0 to pi by 2 and it is decreasing from pi by 2 to pi, therefore neither increasing nor decreasing in which interval? In the full interval 0 to pi. Both conditions are there, right? Both increasing and decreasing conditions are there. That's why neither increasing nor decreasing in which condition? 0 to pi. Simple. Understood? Okay. Chaliye, moving on. Problem 3. I know I took some extra time, but it's okay. I want to explain you the condition. I can quickly solve this question. Let's see how. Fx is defined like this. Greater than 0. When x is greater than 0, it is x minus 3. Find the derivative first. I have to check the trend, right? Increasing, decreasing. First step is find the derivative. At 0, I cannot define it. So I'll be simply 0. I'll be what? Differentiation of x is 1. For 3, it is 0. So I get answer as 1. Now check here. When x greater than 0 is there, what is the condition of f dash of x? Greater than 0. Means what? Decreasing. Oh, sorry, always increasing. So what is the answer? Okay, answer is strictly increasing when x is greater than 0. What is this condition? See, f dash of x is 1 means positive when x is greater than 0. Option number B, strictly increasing when x equal to 0, not equal to x greater than 0. Okay, okay, this is for x equal to 0. If I consider this also, I cannot say strictly increasing, I have to say what? Increasing. If I take this condition also, I have to take what? Increasing. So if I want to say from 0, if I want to say x greater than equal to 0, I have to say what? Either say non-decreasing or just increasing. I cannot say strictly increasing. There is no option like this. Okay, even this is true then. Okay, but this is not definition. Okay, even increasing is true, but we are better to write what? Non-decreasing. Okay, so option B is better answer, strictly increasing when x greater than 0. Okay, आगे बढ़े. So not required, this is not required. Question number 4, any doubt if you have, because you know there's a lot of thinking in the problems. If you have doubt, if you think this part is faster, I did not understand that particular question, or the concept went too faster for me, then you ask me, bacha. You ask me these doubts in the comment section. Okay, I'll try to reply to your queries. The function is defined as fx equals to x cube minus 3x square plus 3x minus 100. Check the trend, check the trend. So what's the first thing we do? Wait, derivative निकाल लेंगे. Y dash, what is y dash? 3x square, how much is this? Minus 6x, right? How much is this? Plus 3, and will be 0, right? So what is my y dash? Please check here. Take 3 common. X square minus 2x plus 1. Yes, yes. Please check here. This 0 I am not taking. 0 I am not taking. Okay. Y dash is going to be what? 3 times of x minus 1 the whole square or not? Check here. X square minus 1 the whole square is 1, and this is what? Simply minus 2x, right? So minus 2x. Okay. Now what did I next? I say about next step. Y dash equals to 0. You're gonna put. So 3 times of x minus 1 the whole square. I'll put it to be equal to 0. I get x equals to what? 1. X equals to what? 1. Okay. Now if you see here, it's a increasing function. Okay. If you put this like this, if you put here x equals to 1 is the only condition, right? Acha, we don't even need to say this. Please see this. Please see, understand this. So I don't have to write this statement. Forgive me. We have to check the interval because they're not asking the interval. Okay, only this part. So y dash is coming as what? 3 times of x minus 1 the whole square. Okay, okay, only on the whole square. Now please see. Only if when x is equal to 1. Only if when x is equals to 1, I get what? Y dash as 0. Yes or no? Before and after, what is it? Before also if you take, this will be positive number because square is there, so positive. After also you take this positive number, so again positive. So y dash is always what? Positive, always what? Positive, except for x equals to 1. It means it is simply what? Increasing function. I hope you understand this. Except for x equals to 1, the function is always increasing. Okay, so it will be increasing in nature before and after because it is a positive number. 3 is a positive number. X minus 1 is also a positive number. Okay, can you move on? Yes. Find the value of x. So we did not need the interval. That's why I did not draw the number line. Find the values of x for which the function fx x cube plus. Okay, over here I'll do the interval. So you'll see. Function is given like this, cubic function. I have to find what? The nature. Decreasing I have to find out. Decreasing. The nature is given over here. Decreasing is given. So let's quickly find it out. What is the first step? Find a derivative. Y dash is going to be what, bacha? X cube means 3x square. Okay. Plus 12x square means 24x plus 36. This will be 0. Right? Right? How do we find interval? Putting this equal to 0. 3x square plus 24x plus 36. This will I'll put what? Equal to 0. So put this. Second step was this, to find the critical point. I can see 3 is common. Let's take the 3 common. Okay. Bring it here. I'll get what? X square plus 8x plus 12 equals to 0. What is the factor of this? 6 and 2. 6 is 12 and 6 plus 2 is 8. So x plus 6 and x plus 2 equal to 0. I hope you understand this. X into x is x square, x into 2 is 2x, 6 into x is 6x, add them is 8x, 6 into 2 is 12. Okay. So this is my, what is the critical points now? Critical points are -2 and -6. -2 and -6, correct? -2 and -6. What is the next step? What is the next step? Please check the next step. Number line I'll draw. -6 will come first. -2 will go here, okay? So check a number on the right of this -2. What is the number on the right of -2? What is my derivative first, okay? So what is my derivative? I'll write it here. Derivative is y dash equals to, how much was this? Y dash is equals to 3x square plus 24x plus 36, okay? Or I can simply see this, no? I can simply see this. X plus 6, x minus 2. I can see this from here also. X plus 6 and 1 second. Just give me one more second, okay? If I want to write the entire thing after factorized form, 3 times of x plus 6, x plus 2. Please check. If I take this 3 common and factorize it over here only, I will get, over here only, I'll get what? I'll get the same thing, same factors I'll get, okay? So I'm just taking 3 outside, okay? I'm not dividing on the other side. When I took it as 0, I kept 3 as it is. So 3 times of x plus 6, x plus 2. Now check the trend. I take a number more than 2, take 0. So not more than 2, more than -2, take 0. If I take 0, this will be positive, this will be positive. So positive. Now take a number less than -6, less than minus, let's take -8. I'm taking -8 now. I'm taking -8 now. Check here. It will be -8 plus 6 will be negative. -8 plus 2 will be again negative. What is this? Negative into negative will be positive. Okay. What about this? Take -5. Take -5. Okay. I'm not putting the values. I'm just looking for the trend, right? So I'm not putting the values. Check what? -5. If I put -5, this will be what, bacha? Positive number, correct? And this will be what, bacha? Positive number, and this will be, please understand this is not 1. Yeah, this is simply positive. I'm not writing the numbers. So -5 plus 6 plus 1, so simply positive number. -5 plus 2, a negative number. Plus into minus is what? Negative in general. What is this trend? Negative. I'm looking forward. What is the trend now says? Trend says this is increasing, decreasing, increasing. Positive means derivative is positive. This is derivative only, right? Derivative positive means increasing, negative means decreasing, positive means increasing again. What are they asking? They are asking us decreasing, right? So what is my answer? -6 to -2. This is my x. Please check the answer. -6 to 2. -6 to -2. Option B. Very simple. Ask for decreasing. Decreasing in only this interval, -6 to -2. Answer is that, okay? B. आगे बढ़े. 6th question. The function fx equals to 3 by x plus 7. 3 by x plus 7 where x is not equal to 0. X is not equal to 0 is decreasing. Okay, whatever is, we'll see the condition. But right now, what is the first thing we know? We'll see the options later. First, we'll know our condition. What is that we know? Find a derivative, sir. What's the derivative, bacha? Please check. For 7 it is 0. But this will become 3 times of -1 upon x square. How, sir? Please check the differentiation. I'm using the polynomial differentiation. It is x power -1. I can write 3 by x as 3 times of x power -1. It will become what? -1. It will become what? I'm using what? I'm using my differentiation rule, okay? X power n. So 3 will be as it is. It will become -1. X power -1. How much is that? 3 times -1 upon x square. Because -1 will become -2. Will come in denominator, will become x square. That's what written here. 3 times of -1 upon x square. Is it fast? I hope it's not fast, okay? आगे बढ़े? Okay. Okay, sir. आगे बढ़ते हैं. So y dash is equals to 3 times of -1 upon x square. Simple, very simple. Okay. Now check here. So my y dash is. So it is actually, think logically. This is positive. The denominator is positive, and this is negative. So basically, it is always what? Negative by positive is what? Negative by positive is always negative, no? Negative by positive is always negative, sir. So it is always negative means what? Always negative means what? Decreasing. So I am getting f dash of x or y dash as less than 0. So what is the function? Decreasing. The function is decreasing. Yes or no? Function is decreasing. But I cannot take x as 0. Why, sir? If I take x as 0, what will become infinity, no? 3 by 0 will be infinity. So it will be decreasing except for the domain where it is 0 is not included. So option A is correct answer. So decreasing for all the real numbers except for 0. For 0 it is not defined only. Okay, आगे बढ़े. 0 is not part of the domain बच्चा. That's why 0 is not there. Seventh problem. Okay, function is given. What is the first step? First step, you find derivative. If the function doesn't make sense to you directly, if the graph will not come directly to you, find the derivative quickly. What are we going to use here? Product rule. X I'll keep it, okay, let's say 1. I'll keep exponential function as it is. I'll take a plus sign. I'll keep x as it is. This will become what? E power minus x, 1 by x will remain as it is. Exponential function will be as it is only after differentiation. We know this. E power 1 minus x, and simply I'll get what? Minus sign. Because I have to differentiate what? Minus 1. I have to differentiate 1 minus x also, right? Chain rule, 1 will be 0, x will be minus 1. Okay. What am I going to get? E power 1 minus x minus, this minus sign will come here. So x times of e power 1 minus x. This is clear, right? This minus sign will come here, will plus and minus will make minus only. So I'm getting y derivative as, what I'm getting, please check. Yes, I can take e power 1 minus x common. It will be 1 minus x. Okay. Now if we know this function is always positive. Any exponential function, the graph looks like this, right? Is it coming below by axis, sorry, x axis? No. Means this part over here that you're seeing is always positive. Okay. Why I'm saying this, you'll understand now. Means the trend, whether the y dash is positive or negative, will depend upon 1 minus x. If 1 minus x part is positive, the function will be positive. If this part is negative, the derivative will be negative. So I can call the increasing and decreasing trend from directly of the nature of 1 minus x, because this exponential part is always positive. Okay. So please check here. Now check the intervals. Strictly increasing interval 1 by 2 to 2. No, because in interval 1 by 2 to 2, what will happen? This will be negative, right? If I put 1 by 2 here, positive, okay? If I put 2 here, okay? No. Alright, what about this? Okay. Now look at option D, very fascinating. Look at option D. 1 to infinity, okay? 1 to infinity, if you check 1 to infinity, what will happen? This is true. 1 by 2 to 2, no sir. Before 1 by 2, what will happen now? Before 1 by 2, this is 1 by x only, right? 1 by 2, okay? So if you put 1, it will become 0, right? Think about it, sir. How I'm validating the first option? In this option, is the answer 1 is there or not? 1 by 2 to 2 will have 1 in it, right? So if you put 1 here, it will become what? 0. 0 means it is not strictly increasing, it's just increasing. If derivative is equal to 0 means it is not increasing. So it is not strictly increasing, it's simply increasing. So option A is incorrect because of the word strictly over here. Okay. Now look at the second, look at the D option. From 1 to infinity, what will happen? 1 to infinity means a number 2 can be taken. Take here number 2. 2 le lenge, what will happen? 1 minus 2 will become what? Will become negative. For any number I keep going from 1 to infinity, this part 1 minus x will be negative. This is always positive. So what I'm trying to say here is y dash will always be less than 0. Correct? From where to where? In 1 to infinity. Where to where? 1 to infinity. Now I can say what? This function is strictly decreasing. Always less than 0 means what? The function is strictly decreasing. Option D is correct. Okay, option D is correct. Strictly decreasing in the interval 1 to infinity. Easy? Asan hai? We said this is positive because exponential function will never be negative, and this can be 0 at 1. That's why I cannot take option A. I can take option A. Option D is validated because of this reason. आगे बढ़े. Let's move on. 8th problem. Okay. The function fx equals to e power ax plus e power minus ax. E power ax plus e power minus ax, provided this is there. Then monotonically, what is it? Increasing. They have given increasing. They ask only one trend, means only one trend. Okay. Monotonicity means only one trend. Whatever is increasing, then only increasing. Decreasing, then only decreasing. चलिए कर लेते हैं. Single trend will check. First is, what is the first step? We'll find y dash. We'll find y dash, sir. What is that going to be? E power ax times a. I will do for e power ax will remain as it is, then ax I'll do, it will become a. Same way here I'll get e power minus ax times minus a. Because for minus ax I'll get it as minus a. What is my y dash then? Take a common, this a I can take common. I'll get it as e power ax, and what is it? Minus e power ax. Sorry, minus ax. Is it right? Please check. Minus will come, this will make this as minus. This minus and this plus will become minus, and this will remain as it is. Okay, sir. Okay. Now, if you understand this, a is positive. They are saying that a is positive, sir. A is positive, sir. Means the trend will be only true for what? Only true for. So this is so positive. So trend will only come from where? From here. From here. Okay. So this is positive means only this part will come. So I'll do what? Y is equal to 0 I'll put. Correct? What I'm going to get? E power ax equals to e power minus ax. Correct? It means what? Ax, what is it? Equals to minus ax. It means what? 2ax equal to 0. I hope you're getting the steps. A is positive means I don't have to consider this, only this part I have to consider for the sign change. So I'm taking derivative to be equal to 0. Why? To find the critical points. To find the critical points, see here, I'm putting this equal to 0. Negative sign is there. Will go on the other side of the 0. Will become positive. This part will become positive. Base is same. Exponent will be same. Exponent is ax and minus ax. Bring minus ax over here, becomes plus 2ax equal to 0. Now check here. Okay. Now check here. Okay. Now a is positive. Okay. If x is also positive, if I check the only positive trend, if I check only positive trend, let's check. I'll not check this negative trend. I'll check only positive trend. If I take like this, okay, A is positive. A is positive. If x is also positive, what will happen? Y dash will be positive. Yes or no? If x is negative, y dash will be negative. Yes or no? Okay. What I'm looking for, bacha? Okay. Please understand this. I'm looking for in the question monotonically increasing. That's why I've taken greater than equal to 0 sign. Okay. Now, if I do that, it will be only increasing if x is positive. So I will not consider this line. This will be not considered. Only if x is greater than 0, which is which option? D option. I will have this condition to be increasing. Right? So increasing condition is validated only because A is positive, 2 is a positive number. If x is positive, then only it will be greater than 0. If I take x negative, the sign will change. The inequality will reverse itself. Okay. So my answer is what? My answer is what? X greater than 0, option number D. Option number D. Option number D. आगे बढ़े? Okay. चलिए. Question number 9. The function f(x) equal to x plus cos x. First thing is what? Find derivative. 1 plus, okay, cos x, right? So minus sin x. Cos x differentiation is minus sin x, right? Now think about it. Can sin be ever more than 1? No. Maximum it can be 1. Maximum it can be 1. Okay. Maximum it can be 1. Chaliye. So if it is 1, this y dash will always be positive only, no? It will always be positive only, right? So because sign range is what? From minus 1 to 1. So for all that value, 1 is here. This can never be more than 1. So for that reason, it always positive. Answer is always what? Increasing. Okay. This is always a positive function. Please understand it. 1 minus sin x is a positive function because 1 is a positive number. Sin x cannot go beyond 1. So positive function greater than 0, sir. Always increasing, sir. Okay. Always increasing function. This is a increasing function. आगे बढ़े. Okay. Yes, right. No doubt in the previous one. Okay. Find the interval on which the function fx, okay, is decreasing, sorry. Forgive me, decreasing. How will we solve this? Same approach, very same approach. Y equals to x minus 1, x minus 2, the whole square. Okay. So, how will I solve this? Please check. Y dash will be what, bacha? I have to do what? Product rule. Let's do for this part first. It will be 1 times of this, x minus 2, the whole square plus. I'll keep x minus 1 as it is, and I'll get this as 2 times of, I'll need more space, I'll write below here. Then I'll get what? 2 times of x minus 2 times 1. Hope you can see this. Please check. x minus 1 I did as 1 because x will be 1 and minus 1 will be 0. I kept x minus 2 the whole square as it is, plus sign x minus 1 was kept as it is. For x minus 2 the whole square I'll get 2 times of x minus 2. For x I'll get 1, so this is like this. Okay, product true, so this is my answer. Y dash is going to be x minus 2 the whole square plus 2 times of x minus 1, x minus 2. Let's do the expansion over here. X square plus 4 minus 2x. Okay. Okay, why I'm doing expansion? I don't have to, right? I can take common, no? I'm trying to factorize it. Yes, I can take common. Okay, but if I take common, I'll get the same answer. But okay, something else will come. Please check here. So I'm going to get this as x minus 2 as it is. What's left here? X minus 2, correct? I've taken x minus 2 common, so one of the x minus 2 is left here, and plus 2x minus 2. Yes or no? I'm expanding 2 with x. 2x, 2 with minus 1, minus 2. This x minus 2 is already taken common. So my y dash is going to be x minus 2, please check here, it will be 3x minus 4. Right? Find the critical point, put y dash equals to 0. Find the critical point, please. Put y dash equal to 0. I'll get x as 2 and 3 by 4. 2 and 3 by 4. Okay, it's not 3, it's 2. It's 2 and 3 by 4. Okay. Okay, 2 and 3 by 4. Plot in the number line. So 3 by 4 will come here, and sorry, not 3 by 4, sir, forgive me, 4 by 3, right? Not 3 by 4, 4 by 3 will be the answer, the critical point, because if I take it equals 0, no, 4 will go on the other side, so 4 by 3. My mistake, calculation mistake, forgive me please. 4 by 3 and 2, 4 by 3 and 2. 4 by 3 is more than 1, 2 is obviously more than 1, so it will come first. First 2 will, then 2 will come here, and 4 by 3 will come here. You have to check the trend, right? Decreasing we are looking for. More than 2 value. Please check here, more than 2. What's my derivative? What's my derivative? Can I write over here? My derivative is this. X minus 2 and 3x minus 4. Okay? I'm taking for what? X more than 2. This will be positive. Okay? Please see the trend here. Positive here. What is more than 2 means? This will always be positive, okay? 3x minus 4 will also be positive, because obviously it is more, this is positive, then 3 times of 2 will be what? 6. 6 minus 4 will be positive only. So positive. So what is this going to be, bacha? This is positive. Let's look at the next one. X less than 2. Let's take this x as 1. Take x as 1. For 1 will be what? Check here. Negative. Okay, minus 1. This is what? Again, what? For 1 I'll have 3 minus 4. Correct? 3 minus 4 will be what again? If I put x as 1, it will become minus and minus. Okay? Will be what? Will be what? Plus. Okay, will be what? Plus. Alright? Okay. But again, I have taken this one change here. 1 is over here, no? 1 is over here. So I cannot take the number right. I cannot take it as 1 because 1 will be on this side. So I can consider, if I'm taking less than 1, basically I can take, I'm considering what? X is less than 4 by 3. Please check here. So actually when I'm putting it as 1, bacha, it is not less than 2, it is actually less than 4 by 3 also. So 4 by 3 also, 4 by 3 also, okay? Because both 4 by 3 and 1 is before before 2. Both 4 by 3 and 1 is before 2. So if I'm checking for x less than 4 by 3 and put x equals to 1, I'll get what? Minus and minus, so becomes what? Positive. So this part is also positive. This part is also positive. So let me just erase this one, not part of the interval. Okay, positive. This will come as negative. This will come as negative. We'll check here what value you can take. So I can take, if I take 1.5, I can take 1.5, right? Let's take 1.5. This will be negative for 1.5. Negative, and this will come as positive. Please check. This will come as positive. Okay. 1.5 means if I put 3 times of 1.5 is how much? 4.5, right? Minus 4 is how much? 0.5. So what is this? If I take a number between what? Between 4 by 3 and 2. For x lying between 4 by 3 and 2. I can rewrite this in a better, clearer answer. If x between 2 and 4 by 3. What I'm taking? X as 1.5. What will happen to the first part? It will come as negative because it is 1.5 minus 2 is minus 0.5. Okay. And this will come as positive because it will come as 0.5. So positive. What is the answer? Negative. Right? Yes or no? Yes. So what is this going to be? Negative. So what is the trend here? decreasing, increasing, decreasing. I'm looking for what? Decreasing. Which is option? Option is this D. Why, sir? 4 by 3 to 2. 4 by 3 to 2. Yes, simple enough. Okay. There was a couple of mistakes. Okay, I took it as 2, but it will be 4 by 3. I did not see the number line. Forgot the number line. No problem. आगे बढ़ते हैं. Simple question. Okay, so last problem of the day. This is the last problem of the day, sir. We have solved 11 question on this trend only. We have solved all the variety of questions. I hope it was very clear. Okay, when we were solving the problems. आगे बढ़े. Let's move on. If the function is given as fx a sin x plus 2 cos x. Why I said this as last function? Because I've taken this question because the differentiation will be lengthier. This differentiation is little bit lengthier. Okay, because I have to use what? For two terms, both numerator and denominator, and will be chain rule. Is there a chain rule? There is no chain rule, I guess, but only quotient rule is there. Okay, let's check. So I will find from here only. Yeah, I have enough space. So let's do from here. So I'll write it as y dash if I'm writing y dash. So let me take the derivative of the first numerator. Then I'll get it as what? A cos x first. Okay. This will become what? Minus 2 sin x. Please see this. A will remain as it is, sin is cos x. 2 will remain as it is, cos is minus sin x. So minus 2 sin x I've written here. What I'll write as it is, sin x plus cos x. Sin x plus cos x, sir. Okay, simple. Quotient rule means a negative sign will come. Now I'm going to keep this numerator as it is. So I'll write it as a sin x. I'll need more space. I'll write from here only. Okay. I'll write from here only. This is a minus sign over here. So I'll write a sin x as it is with 2 cos x. Okay. Now I'm going to do this. This will become what? Sin will become cos x. This will become minus sin x. So I've differentiated the denominator part, kept numerator as it is. Okay. And whole thing divided by what? Sin x plus cos x the whole square. Simple enough? Very simple. Okay. Now see this. I'll do the expansion now. If I do the expansion, my y dash will look like this. Please check. A cos x with sin x. A cos x sin x means simply a cos x sin x. Okay. So this over here and this over here is covered. Okay. Now a cos x with cos x. What I'm going to get? A cos square x. So this with this also is covered. Okay. Now minus 2 sin x plus cos x. What is that? Minus 2 sin x and cos x. So all the 4 terms are considered here. Okay. Anything else I've missed? So yeah, minus 2 sin x with cos x I've taken, but I have to take this also, na? Minus 2 sin x with sin x. So I'll get what? Minus 2 sin square x. So I'll get expansion how many terms? 4 terms. 1, 2, 3, 4 terms are there for the first one. Next one I'll get what? A minus sign will come. Okay. I'll put a bracket over here just to avoid confusion. A sin x with cos x. I'll get what? Please check here. Just little bit patient because I told you little bit calculative in differentiation. No problem. So I said what? A sin x with cos x. Please check. Now a sin x with minus sin x. Yes. Now next what? 2 cos x with cos x. So plus 2 cos square x and 2 cos x with minus sin x. So minus 2 cos x and sin x. Whole thing divided by what? This whole thing. Sin x plus cos x the whole square बच्चा. Okay. आगे करें. Now check here. I'll cancel some things. I'll cancel something. This a sin x positive, a sin x cos x positive, and this minus will apply to this. So this will also cancel. Because if I open the bracket, minus will act on this. So plus and minus will cancel each other. Okay. Now look at this. Minus 2 sin x cos x. Over here minus 2 sin x cos x. And this minus will make it positive. This minus and this minus will make it positive. So I can cancel this and this also. Okay. That's all I can cancel. Next. I have to do it on the next slide. So I will keep coming back. Let me write it here. Y dash equals to what? Minus a, sorry, from the first, a cos square x, here, check here, plus a cos square x. Come back. And this minus will operate on this minus. This minus over here will operate on this minus. It will become what? Plus a sin square x. Okay, so this and this I've taken. Now minus 2 sine square x, okay, I've taken this now, and look at this, I have here what, a minus sign is there with this plus sign, this minus sign with this plus sign, I'll get what, minus 2 cos square x. I've taken how many terms, bacha? 4 terms. 1, 2, 3, 4. Please check here, 4 terms are there or not. 1 term, 2 term, 3 terms, 4 terms. All of them have been taken. All of them have been taken. Now what is the denominator? Simply this. Sin x plus cos x the whole square. Okay. What is my y dash now? Please check. So a cos square x plus a sin square x. I can take a common, it will become simply a. Same way, minus 2 sin square x, minus 2 cos square x. I can take minus 2 common, it will become minus 2. Simple. We know that this part is positive. The square of anything is positive. This is always positive. So the trend will depend upon the sign of this part, a minus 2. Okay. What are they asking? Increasing, they are asking, increasing. So for increasing means y dash has to be greater than 0. Okay. So it means what? A minus 2 upon a positive number has to be greater than 0. It means what? A minus 2 has to be greater than 0. It means what? A has to be greater than 2. I have written a positive number because this is simply positive. I can replace it by some positive number. If I cross multiply, it will become 0 only. So A minus 2 is greater than 0, say A greater than 2. Any option like this? Yes sir, option D. Option D. Okay. So this was it. I hope you understood this. Calculative is there, but not that complicated. Calculative but not complicated. You just do the quotient rule, use the expansion, do the multiplication, cancel out the common terms, and then use the identity. Sin square plus cos square is 1, so that's why a comes. Sin square plus cos square is 1 again, that's why minus 2 comes, and we got this as positive, and that is all from this session, sir. Okay. So I hope this was very, very helpful. Nahi tha? Tha na? Yes. We have taken 11 questions to understand this topic, increasing and decreasing function. In the coming video, you'll see the next part of this chapter. Okay. So keep working hard, bacha. Keep working hard. Be positive all the time. And this is it for the session today. I'll see you in the next session. Please take care. Bye bye.